Let us start the formulae pertaining to coordinate geometry. You see the point of intersection of two lines. Point of intersection of two lines. Let the two lines are a1x plus b1y plus c1 is equal to 0 and a2x plus b2y plus c2 is equal to 0. So we have to find the point of intersection, means where these two lines will intersect each other, and its point of intersection be x1 y1, suppose. Then these two lines will be satisfied by the point x1 y1, means if you just substitute x1 y1 in the first equation, it will be equal to 0. In the second equation also it will be equal to 0. And its point of intersection, that is why the points of intersection is x1 y1. Then these two lines will be satisfied by the point x1 y1. What will be the coordinate? What will be the value of x1 and y1 with respect to the coefficient of x and y and constant? You see, x1 will be equal to, while we are finding x1, at that time we have to cover this x. So cross multiply b1 into c2. b1 into c2 means left to down. Left to down, LD. You see, just to cover the x part, because we are finding the value of x. So you just cover the x part here, and we are left with y and c constant, that is, so left to down, LD, means b1 into c2 minus LU, left to up, b2 into c1 whole divided by a1 into b2 minus a2 into b1. You see, a1 into b2 minus a2 into b1. This is by cross multiplication method. Straightway, if you have understood the left to down and left to up, you can easily find out without detaching the coefficient of x and y and constant. This is the same method that is known as cross multiplication method. So for y, what we have to do here, LU means left to up. First of all, you have to cover the y part. We just cover the y part. Now we are left with x and constant. So left to up, a2 into c1. You see, a2 into c1 minus LD, left to down, means a1 into c2, whole divided by the denominator for both will be the same. Denominator for x1 and x1 and y1 for both will be the same. So here you see a1 into b2 minus a2 into b1. Now the condition for the three straight lines to be concurrent means all the three lines is passing through a particular point. That is known as the concurrent point for three lines. Let the three lines are, first of all, let us take the equation for three lines, that is a1x plus b1y plus c1 equal to 0. That is the first equation. Second equation is a2x plus b2y plus c2 is equal to 0. That is the second one. a3x plus b3y plus c3 equal to 0. That is third equation for the third line. Suppose first and second intersect each other at x1, y1. As above we have discussed earlier. So just to suppose that the first two lines intersect each other at x1, y1. If the three lines meet at each other at x1, y1, must lie on the third line. Means the point of intersection of the first two must also lie on the third line. So you see, a1 x1 plus b1 y1 plus c1 equal to 0. a2 x1 plus b2 y1 plus c2 equal to 0. a3 x1 plus b3 y1 plus c3 equal to 0. On eliminating x1 y1 from these three lines, we have the following condition, that is a1 b1 c1, a2 b2 c2, a3 b3 c3 means the determinant of this value. We have to take the determinant values of this coefficient which has been detached from this equation, three equations. Now the general equation of the line passing through the intersecting point of the two straight lines. General equation of lines passing through the intersecting point of the two straight lines can be given as a1x plus b1y plus c1 equal to 0 and a2x plus b2y plus c2 is equal to 0. These are the two lines and its general equation can be represented by this. You see, a1x plus b1y plus c1 plus lambda a2x plus b2y plus c2 equal to 0 means the complete second equation has been multiplied by arbitrary constant where lambda is arbitrary constant. It is quite obvious that the said equation is of the first order. These equations are of the first order means its degree is 1. The degree is 1, hence it represents a straight lines. Now proceed the next formula, that is angle between the two straight lines. You see there are two lines, that is AB and CD. Let the AB line makes theta angle with the positive direction of x and CD makes the angle theta 2 with positive direction of x. So, and the equation of AB is equal to y is equal to m1x plus c1 and equation of line CD is y is equal to m2x plus c2. Now you see m1, what is m1? m1 is equal to tangent theta 1, m2 is equal to tangent theta 2. Here you see the theta 1 is the exterior angle for the triangle PQR. PQR is a triangle. So theta 1 is exterior angle, so it will be equal to theta 2 plus alpha. So theta 2 is the slope angle of the CD, where alpha is the angle between these two lines. Our ultimate aim is to find the alpha. So let us proceed. Alpha will be equal to theta 1 minus theta 2. Now taking the tangent of both the sides, we will get tangent alpha will be equal to tangent theta 1 minus tangent theta 2. Sorry, tangent theta 1 minus theta 2. So tangent alpha will be equal to tangent theta 1 minus tangent theta 2 whole upon 1 plus tangent theta 1 theta 2. This is tangent A minus B formula has been used here. So tangent alpha will be equal to, for tangent theta 1 I have placed m1, for tangent theta 2 I have placed m2 and 1 plus m1 into m2. So alpha will be equal to tangent inverse in bracket m1 minus m2 upon 1 plus m1 into m2. When the lines are perpendicular to each other, so what will be the situation? Alpha will be equal to 90 degree. Means tangent alpha is equal to 1 by 0. Why? Sine 90 is equal to 1, cos 90 is equal to 0. So I have written here 1 upon 0. Now cross multiply it. So you will get 1 plus m1 into m2, 1 plus m1 into 1, that will remain So it will be equal to 0. So the product of the slope or the slope will be equal to m1 into m2 is equal to minus 1. Means the product of the gradient, you can say the product of the slope of two lines while they are meeting each other at 90 degree, at that time it should be minus 1. If the lines are parallel, at that time the alpha will be equal to 0. So tangent 0 degree is equal to 0 upon 1. Just again equate it. You just cross multiply it. You will get here m1 minus m2 equal to 0. So ultimately you will get m1 is equal to m2. Means the slope of both the lines are equal while they are parallel. If m1 minus m2 upon 1 plus m1 into m2 is positive, means the overall value of this is positive, at that time the alpha is acute angle. When it is negative, at that time alpha will be obtuse angle. Now ax plus by plus c, it is a general equation of a straight line. So transpose all the terms except y to the right hand side. You will get y is equal to minus a by b x minus c by b. Here m means that is the slope of the line, that will be equal to minus a by b. Here you see minus m by b, a by b. Now therefore the ax plus by plus c equal to 0, parallel. This line is parallel to ax plus by plus lambda equal to 0, where lambda is a constant. See, the equation of the lines which are parallel to each other, they differ only by the constant. You see, ax plus by plus c here equal to 0. Here ax plus by plus lambda is equal to 0. Means lambda is the constant, they differ only by the constant. For perpendicular case, where the product of the slope is equal to minus 1, ax plus by plus c equal to 0 is perpendicular to bx minus ay plus lambda equal to 0. Here you see, we have interchanged. We have interchanged the coefficient of x and y in order to get the equation of line perpendicular to the given line. So here you see the bx and ay, and change the sign of any one. Means either you can change the sign of x, coefficient of x, or coefficient of y, any one. Here I have changed the coefficient of y, that is minus a. So you have to remember it. Ax plus by plus c equal to 0 is perpendicular to bx minus ay plus lambda equal to 0. Here the interchange the coefficient of x and y and the sign of any one as well as the constant lambda. Now the length of perpendicular from a given point to a given line. Here the line AB is given to you. Line AB is given to you. There is a point P whose coordinate is x1, y1. From P we have to draw a perpendicular. We have to draw a perpendicular PN to the given line AB. So we have to find the distance, perpendicular distance from the point P to the line AB. So what will be the coordinate of A and what will be the coordinate of the point B? You see, first of all, the equation of the line is ax plus by plus c equal to 0. If you put y is equal to 0 at a, you can find the value of x, that will be equal to minus c by a comma 0. And when you put x is equal to 0, then you can find the coordinate of the point B, that is 0 comma minus c by b. So you have got the coordinate of the point A and point B, which are intersecting the axis at x-axis at A and y-axis at B. So the coordinate is given here. Now this equation can be, you see I have written here ax plus by plus c equal to 0. It can be written as ax plus by equal to minus c. Now dividing both sides by minus c you will get. So again you just convert it in the form of intercept formula form. You see x upon minus c by a plus y upon minus c by b equal to 1. So AB, what is the AB? Means the coordinate of A and B is given. With the help of these coordinates, you can find the distance between A and B. You see, x1 minus x2 whole square, y1 minus y2 whole square here. You see, minus c by a minus 0 whole square plus 0 plus, you see, minus will become plus. So plus c by b will be whole square. After solving it, you will get here, you will take c common, because you are getting c square here, so you can take c outside of the square root. So after taking the LCM of these, you can take AB also, because the square root of a square b square will be AB. Inside the square root you will get root a square plus b square. Now the area of the triangle ABP, I repeat again, area of the triangle ABP, that is 1 by 2 AB into PN. What is PN? I have just taken it, that is the perpendicular distance, let it be D. Say that the perpendicular distance is D, so 1 by 2 AB into PN is equal to 1 by 2 and perpendicular distance, that is C by A, C by A by B, C upon A by B, C upon A by B, root A square, B square. So I have taken mod of it, means only positive sign we have to take. So C upon A by B, root of A square plus B square. So mod sign is there. Into D. D means the distance, that is PN. PN is the perpendicular distance, that is D here. Now the area of the same triangle ABP in terms of its coordinate of the vertices. You see the vertices are given. Minus C by A, 0. Its coordinate is 0 minus C by B. Its coordinate is, means the coordinate of the point P is x1, y1. So here you see the area of the triangle ABP in terms of its coordinates of the vertices. Formula which I have used here is 1 upon 2 inside the bracket x1 y2 minus y3 plus x2 into y3 minus y1 plus x3 in bracket y1 minus y2 bracket closed. So now we have to work out the area of the triangle ABP is equal to 1 by 2 minus C by A inside the bracket minus C by B minus y1 plus 0 into y1 minus 0 bracket closed plus x1, that is x3 into y1 minus y2. So x1 inside the bracket, that is 0 minus in bracket minus C by B. So once you solve it, you just multiply it, you will get c square by ab. 1 by 2 it outside of the bracket. Inside it you will get c square by ab. Again you multiply to minus y1, you will get plus c by a y1. Here you will get 0. This part will become 0. Now proceed to this point. X1 will be multiplied to minus c by b, means minus and minus, that is plus. So you will get x1 c by b. Now you can take, you see here you are getting c, here also getting c, here you are getting c square. So you can take out c, and 2, 1 by 2 is already outside of the bracket, that is c by 2. Inside the bracket you will get ax1 plus b1y plus c upon whole upon ab. This will be your second formula, second equation. Now equating the first and second. Now equating the, because it is also area of the same triangle, it is also the area of the same triangle, but it is with the help of the vertices, and the first one, it is the based on that geometrical formula, that is 1 by 2 base into height. So now equating the first and second, we get 1 upon 2 c upon ab root of a square plus b square mod into d equal to c by 2 inside the bracket ax1 plus by1 plus c upon AB. Now this is AB and AB will be cancelled, 2 and 2 will be cancelled, C will be also cancelled. So we are left with root A square B square into D equal to AX1 plus B1 BY1 plus C. So D will be, means the perpendicular distance can be given by AX1 plus BY1 plus C whole divided by A square plus B square, root of a square plus b square. Note, perpendicular distance from the origin means 0, 0. You just put the in place of x and y, 0, 0, you will get c only on the in the numerator part. That is why I have written here to a line that is c upon root a square b square, a square plus b square. Distance between the parallel lines, that can be worked out by with the help of the difference of perpendicular distance, from the origin to the line. This will be now the bisector of the angle between the two lines. You see there is two lines AB and CD. The bisector has been drawn. EF is the bisector of the angle. From there is a point on the bisector P. From P we have dropped perpendicular, that is PN and PM, and these perpendicular distance from the arms of the angle will be always equal. Perpendicular distance is always equal. So there is a point P on the bisector EF such that PN is equal to PM and PN is perpendicular to CD and PM is perpendicular to AB. Coordinate of the point P is x1, y1. So just substitute the value a1 x1 plus b1 y1 plus c1 whole divided by root of a1 square plus b1 square is equal to plus minus a2 x1 plus b2 y1 plus c2 whole divided by root of a square plus b square. Now proceed further. This is the required equation of the bisector of the angle between the two lines. You see what we have done here. that we have substituted the coordinate of the point P. You see x1, y1, x2, x1, y1 in both the cases. But it has been divided by a1 square plus b1 square. Here it is divided by root of a square plus b square. This is the required equation of the bisector of the angles between the two lines. Now, a1 x1 plus b1 y1 plus c1 whole divided by root a1 square plus b1 square is equal to plus a2 x1 plus b2 y1 plus c2 whole divided by a2 square plus b2 square is the equation of, this is the positive value, so it is the equation of EF, because the point P lies on it. Point P lies on it. If you take the negative sign of it, if you take the negative sign from here, if you take only the negative sign at that time, then that will be the equation of the bisector, which will be HK. It will be the equation of bisector HK. So here I have written separately a1 x1 plus b1 y1 plus c1 whole divided by root of a1 square plus b1 square is equal to minus a2x plus b2y plus c2 whole divided by a2 square plus b2 square. And P, here the P does not lie. You see, once you are taking the negative sign, P does not lie. P does not lie on the HK. So I have mentioned it here. P does not lie on it. Is the required equation of the HK bisector.